Welcome to G Fun Facts Online. In quiet, climate-controlled vaults around the world lies a treasure trove of cosmic history. It's not on hard drives, but on millions of delicate glass photographic plates, each a frozen moment of the night sky from a bygone era. For over a century before the first satellite, these plates were our main window to the universe. Today, scientists are blowing the dust off these celestial cold cases, using futuristic technology to solve astronomical mysteries and rewrite history. These plates, made between the late 1880s and the 1990s, form a unique, century-long movie of the heavens. They allow us to do what's called time domain astronomy, studying how things in space change over time. Supernovae, variable stars, even undiscovered planets, all were unknowingly captured, waiting for us to find their secrets. The problem was, analyzing them meant physically handling the delicate glass, a process so slow that most of the information remained locked away. But now, a technological renaissance is underway. Ambitious projects are using high-speed scanners and AI to turn these glass artifacts into a flood of digital data, placing over 100 years of observations into the hands of a new generation. Before the age of digital cameras, the photographic plate was the hero of astronomy. These glass plates, coated with a light-sensitive emulsion, could gather light for hours, revealing objects far too faint for the human eye. They provided a permanent, objective record of the sky. Starting in the late 19th century, observatories began systematic all-sky surveys. The Harvard College Observatory, under director Edward Pickering, launched a program to patrol the entire sky, night after night. This massive project, which ran from 1885 to 1993, created the world's largest collection of over 500,000 plates. This work was a monumental human effort. At Harvard, a group of brilliant women known as the Harvard Computers were hired to meticulously analyze the plates. Despite the societal limitations of their time, they made foundational discoveries. One of them, Henrietta Swan Leavitt, discovered a crucial relationship in a type of star called a Cepheid variable. Her discovery turned these stars into, quote, standard candles, allowing astronomers to measure vast cosmic distances for the first time. It was this very breakthrough that enabled Edwin Hubble to prove that the Andromeda Nebula was actually a separate galaxy, shattering the view that the Milky Way was the entire universe. And it all started with someone painstakingly analyzing smudges on a glass plate. The value of these plates goes far beyond that. They hold pre-discovery images of supernovae, allowing us to see what the star looked like before it exploded. They contain the faint trails of asteroids and comets identified decades later. In fact, to prepare for the New Horizons flyby of Pluto in 2015, scientists digitized over 800 plates taken between 1930 and 1951 just to refine the spacecraft's trajectory. Every plate is a time capsule. For decades, though, this potential lay dormant. Manually inspecting a plate with hundreds of thousands of stars was impossible. To unlock this glass universe, it needed to be translated into the language of the 21st century, digital data. This is the mission of projects like DASH at Harvard and Applause in Europe. They developed custom, high-precision scanners to digitize the delicate plates without damaging them. The DASH project, which finished its two-decade scanning effort in 2024, has digitized nearly 500,000 plates, creating a public database of light curves spanning over 100 years. Once digitized, AI, enhanced software, takes over. It performs astrometry, which is precisely mapping the coordinates of every point of light, and photometry, which measures each object's brightness. This is incredibly complex, as it has to account for distortions in the old telescope optics and degradation of the plates themselves, like scratches and dust. This digital renaissance has transformed a century of observations into a searchable, analyzable dataset. It's a new kind of telescope, one that lets us rewind time and watch the cosmos unfold over 100 years. This allows us to investigate some of the universe's most perplexing cold cases. Perhaps the most famous is the enigma of Tabby's star, KIC 8,462,852. Discovered by citizen scientists, this star shows bizarre and extreme dips in brightness, sometimes by as much as 22%. The data was so strange it led to wild hypotheses, from a swarm of comets to the tantalizing idea of an alien megastructure. To investigate, astronomers turned to the newly digitized Harvard Plate Archive. Could the star's behavior be a long-term trend? An initial study suggested the star had been dimming for a century, deepening the mystery. However, a more rigorous re-examination of historical data found the star's brightness had been mostly constant, though it did find a significant 8% dip back in 1978. While the plates didn't solve the puzzle, they provided crucial context, ruling out certain long-term models and proving that the current best explanation is likely a massive cloud of ordinary dust. These archives are also full of